Okay, so for our second day at 2.5, we're going to talk about conjugate pairs. And I've used the words often. I've said the conjugate pairs, the conjugate pairs. So when I had 9x squared minus 4 over here, I said they're conjugate pairs. So it was 3x plus 2, and what's the other one?
3x minus 2.
3x minus 2. So the whole point of that is the difference of squares. When I multiply it out, that middle term zeroes out, correct? Okay, that goes for imaginary numbers. What it says, if one conjugate pair is a 0, then the other conjugate pair must be a 0. So if I'm listing, if I say, use the following zeros to find the rest of them, and I tell you that 3 minus I is a 0, what also has to be a 0? The other conjugate pair, or 3 plus I. So conjugate pairs have to be there. You can't just have one of them. That only goes for imaginaries or square roots.
It only goes for imaginary?
Yeah, because with this, if I told you that, if I just told you that 2/3 was a solution, obviously not every time is negative 2/3 going to be a solution. But the reason why the conjugate pairs have to be a solution is what happens when I multiply this out. What do I get? I get 9, then minus 3i plus 3i minus I squared. Well, this is 0, right?
Yeah,
And this is negative 1, so negative 1 makes it a positive 1, so it equals 10. So do I get a real solution? Do I get a real number that I can work with? Yes. Okay, so that is why when we deal with conjugates, with one is there, the other one has to be there. It has to be, every time. So if I had f of x equaled x squared plus 1, and it only goes if it has real coefficients. So this would be x plus I and x minus I. They both have to be there. Now what this is going to do for me is allow me to use synthetic division in an easier way. Because I can do synthetic division with negative I and positive I and that, but it's a lot easier just to multiply it out and maybe use long division rather than synthetic division. Okay? So this would be a great review for long division. So it says find a 4th degree polynomial function with real coefficients of -1, -1, and 3i as zeros. So we've had problems like this where they tell me my zeros, I have to put them back into what? Where do zeros come from? Before they were zeros, they were what? Factors. Before they were factors, they were a polynomial, correct?
Yes.
Okay, so what factor did -1 come from? X plus 1. What factor did -1 come from?
X plus 1.
What factor did 3i come from? But if 3i is a 0, what also has to be a 0?
X plus 3.
Well, yes. A 0 would be negative 3i, but the factor would be, see how I'm correcting you? This is a 0, this is a factor, right?
So why did we do that?
Well, because it says find a 4th degree polynomial of a function with the coefficients of -1, -1, and 3i.
There's going to be 4 zeros.
So it's going to be 4, it has to be 4 zeros. They don't all have to be real. Obviously, 2 of them are not real, correct? But I have 2 real. Yes?
Okay, I get why we have x plus I, or x plus 1, x plus 1, because those are both -1. But then, why wouldn't we have x minus 1?
Yeah. If we have to find zeros.
No, they gave you the zeros. These are the zeros.
Okay.
That is x equals negative, okay. That is x equals -1. Set it equal to 0. What would you do?
X plus 1.
X plus 1.
Okay, but then why do we have a x minus 3i or an x plus 3i?
Because if this is here, what also has to be?
Because it's a
It's a
Okay.
conjugate pair. It
Okay,
has,
but only that one has to be a conjugate pair, not the other one?
because it's imaginary. Only follows imaginary
or a square root.
or square root.
So it only has to be conjugate if it's imaginary or square root.
Mm-hmm.
I'm looking at my socks.
I'm just looking at the floor. There's nothing there. I'm just looking at the. Okay, so I don't have a polynomial yet. How do I get a polynomial?
You got after, or no.
I've multiplied out, right?
No, I will.
So I multiply this by itself, so I get x squared, 1x, 2x, so plus 2x, plus 1. Now when I multiply those two together, the whole point is to get real numbers, yes? Is there going to be a middle term? No. Because I'm going to have x squared, and I will have plus 3xi and minus 3xi, so that is 0. And then I will have minus 9i squared,
Which will be plus 10.
and it's going to be a plus. So now what do I have to do with these two?
Multiply.
I have to multiply them out. So you multiply them and I'll multiply them, and we better get the same answer.
Did you cross out 9i squared?
No, there was negative 9i squared, so it became a positive I, or positive 9.
Wait. Okay. I squared is negative 1.
Yes. So it was negative 9i squared.
So wouldn't it be plus 9, or like plus 9, yeah, but wouldn't it be plus 1 then? Or no.
No,
never mind.
it's multiplied. I think I got it.
Are you adding them?
I'm multiplying them.
So how'd you get 3x?
Yeah, where'd you get 3 of?
Oh, I don't. I added.
I'm wrong.
Okay, just FOIL.
So you changed.
I got 11x squared.
Well, sure, I got 10x
How did
squared
you get 11x squared?
I got 10x squared.
because wait,
You get 9x squared?
Oh, I didn't do 9x squared, did I?
No.
So then 9, so that would be 10. So you should have x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. I knew it had to overlap somewhere, and my brain was not finding it.
I don't know where I got another x squared because I got 11x squared.
Well, because it should be 9x squared and 1x squared.
Well,
wait,
Where
the
did I go
first
wrong?
x squared isn't the 9.
I don't know. Did you do it? Did you accidentally do the 2?
I don't know where she got the 10x squared. What do you mean?
Okay, I have 9 times x squared is 9x squared. I
Yeah.
have x squared times 1 is
Oh,
1x
I had-
squared.
Wait, what? I did x
What
squared
is
plus
this
10.
Oh, because you were like probably already doing it in your head, like saw that it was.
Yeah, because it was like 9i squared, so
Or you did what I did and added. Like when I got 3, I added.
I did we have like x minus 9i squared, which would be positive 10, so I did x squared plus 10 in the main equation.
Oh, okay. Oh, you added there instead of multiplied.
Yeah.
So before you multiplied everything, you changed 9i squared to 10.
No, don't listen to her. That was wrong.
Oh, I know, but I don't understand what happens in the I. Like, when I
Okay,
multiply that.
This right here was x squared minus 9i squared. What is I squared?
Negative.
Negative 1. So this is negative 9 times negative 1, which is 9. Positive 9.
I went wrong.
Negative 9 times negative 1 is positive 9.
So how'd you get a 10?
Because you have 9i squared, and you have 1i squared, so you have 10i squared, or 10 squared, no i's. I just didn't write it. Okay, let's do it again. Find a polynomial function that has the given zeros. 5, 3 plus 2i, and what do we also know has to be there?
3
3
minus
minus
2.
3 minus 2i. Now, there's a couple ways to do this. Now I'm going to only do it. Okay, what factor did
X minus 5.
x minus 5? Now,
Are we
this
still
whole
trying to
thing,
find to the fourth polynomial?
nope, it just says find a polynomial function. Okay, if it said fourth, I only have 3, correct? So I'd have to make one of them a double zero, wouldn't I? And that would definitely not be the imaginaries, it would be this one, wouldn't it? Okay, now, this is one number. And this is one whole number. So that factor was what?
X minus
X minus 3 plus 2i. And that was one whole number. See that? Okay. And what was the other one? X.
plus
Nope.
X
Because
minus,
this isn't negative. This is not negative out in front of here. So it's minus what?
3 minus 2.
3 minus 2i. Now, what would I do with this negative before I do anything else? I would distribute it on both of them, yes? So I have x minus 3 minus 2i and x minus 3 what? Plus 2i. Do you still see the conjugate going on there? Because the 3's are both negative, and that's supposed to be right. They have the plus and the minus between the two terms.
Why don't you write a plus up there?
What?
On the top one, why don't you
On which one?
on the top one. Right, like now you have the two
They're-
column.
They're both, this
Because
whole
you have
quantity is
negative.
positive. I was circling this, like showing you there's no negative there, so you don't make it a positive. There wasn't a negative. Okay, so what should I do with these two things?
foil.
I should FOIL them out. Because I don't want to work with that, do I? When I FOIL those two things out, is there going to be any imaginary numbers left? There should not be, because that's what conjugate pairs are supposed to take care of, right? So do it. You should have gotten x squared minus 6x plus 13. Yes. get that.
Oh, you got it.
Oh, I actually got that.
Yeah, I knew the.
You can do that
Wait.
one.
And then do we times that by?
Then we have to times that by x minus 5. So if you got x squared minus 6x plus 13, go ahead and multiply it by x minus 5. Because we're not done. We don't have a polynomial yet, do we? No. Yeah, I would get 65 too if I multiplied, right?
I'm really confused at your work because I don't know, like, what are all the answers of, like, how, when you, FOIL,
Mhm.
and then, cause like, all I see is +9, -6i, +4, and I don't know how you got x squared -6x plus 13. Cause I don't know where that 13 came from. I know, but where does 13 come from?
X times 13.
She means like ignoring the
Oh,
plus five.
Okay, here, this turns to +4, and 4 and 9 is 13. I thought you were on the next step, sorry.
Oh my god, I got x squared minus 6x plus 13.
Good job. Now multiply times x minus 5. My 5 won't show up, that's a 5.
Where'd you get 6i from? Did you just take -3 times 2i?
I just distributed each.
Yes.
What I have is this first row is times my x. This first row, the next row I distributed my -3, and then I distributed my -2i. Lining them up that way, I have all my like terms. Do you see what I did?
Yeah.
I lined up my like terms so I don't have to go hunting.
I got it.
Good job. I had a kid about 10 years ago. He's like, why don't you just do this? I'm like, oh, that's much easier. Anytime I do anything bigger than a 2x2, I'll usually line them up like this. I am not a box fan. Anybody use a box in here to multiply? Like a grid. You set it up. Like if you have these two things.
No.
So you'd have x squared minus 6x and
I
13
actually did that last
and x minus 5. Okay, I see a place for that because if you have bigger than two binomials, it kind of gets confusing. So I see a place for that, but the formatting of the box bothers me. It takes me forever to get it exactly right because I think all my boxes need to be the same size and all that kind of stuff.
Well, it just.
So is that our answer down there?
Yep, this is our answer. So what I do is he's like, you could do this. I'm like, I like this, lining them up. Because especially think about it, I had like a 4x4. And I had to multiply it and make that box. The boxes just get absolutely huge. This way I just go down each line, and if there isn't any conjugates involved, everything should just keep moving over and lining up, shouldn't it? There's less holes in the second time than the first time. Connor, did you have a question?
So if you do the box, you just say x.
Yeah, so if you do the box, it's like a multiplication chart. Yeah, so it'd be x cubed minus 6x squared, 13x, and then -5x squared, 30x minus 65. And then when you do the box, any like terms are going to be on the diagonal. If there are any. Sometimes you don't have like terms, so they're not on the diagonal. I do teach that in Algebra 1 because some kids need that, but I personally like just lining them up. Okay, so we found the zeros. Now we're going to find polynomials with those zeros. Okay, you're still going to be finding zeros throughout the day today, but this is just like the new concept. So find a polynomial of the function with the real coefficients that have zeros at -5, -5, and 1 plus the square root of 3i.
This is the same thing, right?
Same exact thing as we were doing. So we know -5, -5, there's a whole numbers, right? They're just what they are. We have 1 plus the square root of 3i, so we also have to have what?
1 minus.
1 minus. And put parentheses around that, guys. We also have to have 1 minus the square root of 3i. And when I do anything with this, that I is going to go in the front for me of the square root, just so that I don't lose it. But you can keep it in the back if you want. So what factor did x minus 5 and x minus 5?
X plus 5.
So x plus 5 and x plus 5. What factor did that 1 plus square root of 3i come from? X minus the quantity of 1, and I'm going to put 3, I square root of 3, just so I don't lose that I. And the other factor is
1 minus
x
X
minus
minus
1 minus, yes. I knew what you were trying to get at.
I was like doing it backwards.
When you're trying to write it and say it at the same time, it doesn't always work. Watch me.
So is it all? How do you know if you're doing x minus or x plus?
What do you mean? Well, it's just whatever. They gave me a plus, so it's gonna be minus. If they gave me minus, it'd be plus.
So if it was like negative 1 minus.
If it was -1, that -1 would stay there in both of them. It doesn't change. It's the middle term.
Okay, so you just add an x basically.
No.
I
Like-
don't know how you did x minus whatever.
Maybe X minus.
Oh,
minus
this, because this is equal to x right now, and I want it equal to 0, so I have to subtract that whole quantity over.
Okay, so if it was had a negative outside of it, it would be x plus.
It would, you would still, it's a quantity, you're doing a what if, it's gonna mess you up. It's a quantity, so you're subtracting the quantity or adding the quantity. If it was a minus, but it was out in front of the whole thing, then yes, it would be a plus, but if it was only on the one, you would have to move them over separately. Now, the other thing, just a second, Tori. The other thing people like to do instead of setting it up like this, they will put 1 plus I square root of 3 equals x. Okay? So I'm going to move these both back over, yes? So what would it do to the 1? Minus. What would it do to the I square root of 3? Minus. Now, what if I have the 1 I square root of 3 equals x? What would it do to the 1?
Negative 1
Negative
plus I square root of 3.
Negative 1 plus I square root of 3. Either one is going to give me my factors, because here I would distribute my negative, and I better get the same thing, right? Let's see if I do. Do I get the same factors there and there?
Yes.
Yes. Okay, either way you want to do that, but if it says it wants it in factor form, these are the factors. One of them says do it in this, and then do it in this. They want the factors. Are these factors, like, this isn't, well, I guess it would still be considered the factor. Okay, Tori.
Okay, so say we were given x minus 3x squared, then it would be x plus x plus. Right? Or am I-
Yes. It'd be plus the first, but the middle term is always going to be that conjugate showing up.
Okay.
The first term, both of the ones are positive.
Yeah.
So if those ones were negative, they would be positive, but you have to have that conjugate pairing right here and right here.
Okay.
You have to have that conjugate pairing. Okay, now what do I have to do?
Now we FOIL.
You have to FOIL everything, so get going. You're going to have to FOIL how many times here, guys?
4. Oh,
3.
Because
The X and the
You're going to do
five.
these two, and then you're going to do your,
yeah, but I have a question. So when I multiply those last two ones,
mm-hmm.
is it I multiply x times I square root of 3? Is that all
Yes,
together?
I squared of 3
I
is
don't multiply by
multiplication.
there, okay.
Yep. And I personally always do my real ones first, because then I get done with it. I'm like, "Whew, I'm done."
minus 2x plus 4.
So I just saw when I was doing this. I'm like, I'm wrong.
So I did everything.
Yeah.
To finish the problem, and if I would have gotten that one, I would have been better.
When I was doing that, I'm like, wait a second. I multiply.
I have a question. Would negative I square root of 3 squared just be 3
Plus 3?
plus 3?
Yes.
So I would have that right answer.
Yes.
I got everything except for the minus 14x squared, because instead of getting 2x squared, I got 25x squared.
Yes, it should be 25x squared. I am not doing well with multiplication today. I'm losing track of where I'm at.
In
Evidently.
conclusion, I got it.
So 25, so this could be a plus, right?
Yeah, plus 9. I think.
25. So that'd be 29, so yep.
Yeah, I got it right.
I really hate the perspective that I have on the board. It's really bad because you're really close, so you can't see the whole problem at one time. It bothers my brain. I don't know who was first.
She was.
Okay.
They were. Where'd you get negative 3i squared?
That's the same question.
Okay, so I have right here times right here.
Yeah.
The square root of 3 times the square root of 3 is what?
9. Well, square root of 3
Times the square root of 3 is,
square root of
which is
9.
3.
Yeah.
And then I times I is
Squared.
I squared. Okay, Tori, your question?
Okay, well, can you just come look at my work really quick, because I didn't even get close to that. And
I know, I got something
Okay.
different too.
you can just move on and,
Well, not yet.
I got something completely different.
And,
as well.
What did you find your work? Did you go through your work and
Yeah, I'm looking through it right now. Cause I got 40x,
pretty
and I
much
got negative.
when I foiled it out, I didn't
Oh,
know.
with the 2.
did you start here right?
I started with that side right, with the 5x, or x plus 5.
I found my
started
mistake.
with, I got x squared plus 10x plus 5. But then the next one I got x squared minus 1x minus xi to square root of 3 minus.
Okay, see like this, look, this should zero out. Every imaginary part should zero out. So that's gone, so I have x and x is negative 2x, and 1 and 3 is 4.
I did not. I did that. I got that.
Okay, I think there is another slide that I want to look at the instructions with you, and that's it, because it's one of those things where you've done it, the instructions just make it look absolutely horrible.
So when are we having a study session?
We did the factoring already, we've done that.
I'll do it at 9
Okay, it says find all the zeros of, now, it says find all the zeros of, but they tell you that 5i is one of them. Okay,
That means negative 5i is one of them too.
that means negative 5i is one of them. So what you might want to do instead of, before we do synthetic division, yes? Yeah? But you might want to do x minus 5i and x plus 5i, multiply those out, and you would get x squared minus 5i plus 5i, so it'd be 0, minus 25 I squared,
Which is
which
just
would make it
25.
x squared what? Plus 25. And at that point, you would probably want to do long division, which would be awesome to remember and
You
review.
just do x squared plus 25 long division to the
Right.
big problem.
But
Okay.
don't forget your 0 in there.
Yeah, you gotta fill in the 0.
Yep.
Okay.
So
makes
that's
sense.
it's exactly like what we've done.
That makes sense.
It's wonderful review today.
Yeah.